Hello and welcome. Today we're going to continue our discussion of Objective-C. We're going to talk about the role of views and view controllers in iOS 5. We're going to talk about some design patterns, a couple of very important ones, target action and delegation. And we're going to talk about the application lifecycle very briefly. First of all, a view is what we see in a running application. A controller, or a view controller, is the object that controls the view. There is a one-way communication between the view controller and its view. We can look at we can see the actions and the objects of the controller as controlling the outlets on a view, and we're going to talk about that in just a second. So the first of our design patterns we're talking about is target action. Now, target action has to do with what happens when the user interacts with the view. The controller declares outlets on the view and also methods or actions that will be called when the user interacts with something on the view. These are both declared, as I said, by the controller. Outlets refer to controls. They are declared as properties. Controls like a label or a text field or even a button can be changed. The text on a button can be changed. And if we do that, we can use an outlet to do that. Actions are methods that are called by the interaction with an object on the view. But the important thing to remember is that both of these declarations happen within the controller, not within the view. So what we do is in a piece of Xcode called Interface Builder, we hook up the actions that respond to events in the view to methods in the controller. And we'll see how to do that in just a moment. We also hook up outlets in the controller to objects in the view. So let's look at how we do that. I'm going to start a new Xcode project, and for simplicity, we're going to use a single view application, and I'm going to call this demo. I'm going to save this in the proper directory. And our application is loaded up from a template. Let's look at our storyboard. First of all, we notice that we have a view controller. And that view controller has a view. If we look at the properties of the view controller, we can actually just right-click it. We can see that the view controller's view is this view. So view controller has a property called view. And that property is actually pointing to the view in our storyboard. So again, as I say, a very simple application. What we're going to do is take a UI label object and drag it to our view. And we'll extend it and center the text and center the label itself in the view. And then we'll also take a UI button object. We can see its object, its class name here, UI button, and we'll drag it as well. And we'll just double click that and change the text to something like say hello. Now, we have two objects on our view. We have a UI label and we have a UI button. But if we run this now and we click on the say hello button, nothing will happen. The reason is that even though we have these two objects in our view, we haven't hooked them up to anything in our view controller. So let's do that. We need a property. We're going to use a new keyword here, and we're going to use strong. Strong says, I don't want this variable to be released by the memory management system during the life cycle of my program. I want it to be retained. We're going to talk about memory management in the future, but for now, it's a good idea to make your properties strong. And again, we're going to use the non-atomic keyword as well, which we've already talked about. Now, this property is going to refer to our label. Our label is an IB outlet, and it is a UI label, and it is a pointer because it's allocated on the heap. All Objective-C objects are allocated on the heap. They are all pointers. So we're just going to call this display. We're also going to need an action. This is an instance method, not a class method. IB action. Remember that keyword. And the selector is the name of the function. We're just going to call it button pressed. And we're going to refer to this not by ID for now. We're going to refer to it directly by its class name, UI button. And again, it's a pointer. Sender is what we are calling the object that sent the action. So we have a pointer to that as well. In our view controller, we'll go ahead, in our implementation, we'll go ahead and synthesize that display property. And then we'll write the definition for that action. And it comes up for us there. You just get rid of the rest of it, and there we go. Now, for now, that does nothing. We'll fix that right now. What we're going to do is take that display object and set its text property to a string. Now, the @ sign might be unfamiliar to you. The @ sign we haven't talked about. This is telling us that this is not a C string constant or a char star. It is a NS string constant, which is an Objective-C object, a iOS object, and NS string sort of wraps the idea of a C string and extends functionality. One of the things I ask you to do at the end of this demonstration is to look at the NS string class and read about it. But we're just going to, for now, set this to an NS string constant, hello world. We're still not quite done. Even though we've got a display and we've got an action, let's go back to our storyboard. And now we're going to hook up that IB outlet and that IB action. To hook up the outlet, we're going to hold down the control key, click on View Controller, and drag from the View Controller to the label. And we see outlets, and the outlet we're interested in here is display. So now that label is hooked up. We're also going to drag from the button, Control, drag, back to the View Controller, and we're going to hook up that action, Sent Events. And Sent Events, the event we're interested in is button pressed, the one we just defined, the IB action we just defined. And now, when we run this application, and it will compile and link and copy the resource to our simulator, we see that we have our label as label, we have our button as button, IB UI button and UI label. And when we click the Hello button, the text of the label changes to Hello World. So it's a very, very simple application, just demonstrating how to hook up a IB outlet and an IB action. Remember that our outlets are hooked from the controller to the view, and actions are hooked from the view to the controller. So that is the target action pattern. Happens very often in every application. We also have another pattern called delegation. Delegation, I always think of delegation as being a child in a classroom. The teacher is the controller, and the children are the views. And one child raises his hand now to ask a question. The teacher can choose to do several things. The teacher can stop what they're doing and answer the question. The teacher could continue to talk and then ask what question the child has. Or the teacher, if they're a bad teacher, could ignore the question entirely. Well, that's sort of delegation. The view in a delegation pattern is broadcasting and saying something's going on here, something just happened, did happen, or something is about to happen, will happen, or maybe asking if something should happen. In other words, should I do this? Should I not do that? So the view is saying something's going on. The controller is saying, okay, I'll handle it. The controller picks up that broadcast. Now, it doesn't have to be that view's controller. It could be some other object responding to that. So the view isn't directly talking to the controller. The view is saying, hey, out there, someplace, I got something that just happened. Does somebody want to handle it? That's what's going on there. The mechanism, the delegation mechanism happens by something in Objective-C that we call a protocol. We're going to talk about protocols in a later lesson, but for now, just be aware that this delegation pattern happens because of magic that we call a protocol. So let's look and see where we can implement delegation in our application. Well, there's a couple of places. If we look at this file, the app delegate is going to respond to delegation methods that are called by the application. The application will say, I'm about to resign active, or I'm about to enter the background, or I'm about to enter the foreground. I just did enter the background. I'm about to enter the foreground. I just did become active. I am about to be terminated. What do you want to do about it? Well, in the app delegate, we notice that none of these methods, even though they're all required by the protocol, none of these methods is being done anything with. They're all commented. So here's an example of the controller essentially ignoring the delegates. Yes, the controller defines the method, but it defines these methods with an empty body. There's another place that we can look for delegates, and that's in the view controller itself. We notice that we have a bunch of methods here that we did nothing with. We have things like view did load, view did unload, view will appear, view did disappear. And in these cases, we're just calling this method on this view controller's superclass every time. We're passing it up the line. We're giving the superclass a chance to respond to these methods. Well, that's how that works. So let's make a small change here. And in view did load, which will be called the first time the view loads in our application, let's change the display's text to an NSString constant of nothing, an empty string. So now, in our storyboard, remember that display, this label, has a string constant of label in it. Well, what we're doing here is when we run this file, the first time that view comes up, we're going to just change displays.text property to nothing at all. So when we run, even though, remember, in our storyboard, we had the text label here. Now we have nothing at all because we responded to a delegate in the view, and we responded by blanking out the text in the label. Now, of course, when we click say hello, that text gets changed because in the action we're changing the .text property to hello world. So that works exactly as it's supposed to. I also wanted to mention a little bit about the application lifecycle. This is the main function. It's in supporting files when you want to find it. The main function starts everything. Objective-C is a strict superset of C. Being a strict superset of C, it has to have a main function. It has to be called main. It has to return an integer, and it takes 2 parameters, and we've already talked about that. Now, what is happening here is a function called UI application main is being called. UI application main essentially is our main event loop. And this loop, this function, will loop until the application is terminated. We pass in the count of arguments and the array of arguments if that even exists. argc in most applications, 99.44% of these applications that we write is going to be 1. It'll be the name of the running application. But we see here that appDelegate is getting a chance to execute before the run loop is entered. And appDelegate has a chance to respond via delegates to these various events. So that's a little bit about the application lifecycle, and we'll certainly talk more about that. So to wrap up our discussion of controllers and views, controllers communicate with views. Views don't communicate directly with controllers. Indirectly, yes. Directly, no. The view has delegates that you might think are communicating with the controller, but they're not. Those delegates are broadcast things. The controller, if it wants to adopt the protocol that those delegates are in, it can implement the methods, but it has the option, as I say here, even with required methods, it can implement the required methods with an empty method body, effectually ignoring the method altogether. So the view doesn't directly speak to the controller. The controller controls the view. So for further reading, I would like for you to read up on UIViewController, the class, and also NSString. It gives you a good introduction into iOS 5 objects, their methods, and their properties. And also in the Apple documentation, it would be a good idea to expand your knowledge of protocols and also look into categories and extensions. Thank you very much, and we'll talk to you soon.